Hello, and welcome to a new video in the Dlubal tutorial. In this video, we will show you how to model a parametric steel platform in Rhino Grasshopper and export the results to RFEM 6. We start with the geometry. We create a point by double-clicking the canvas and writing point. As we mentioned in the previous video, this point is orange. That means it does not contain any data. We can insert data in this command by right-clicking the command and selecting Set One Point. Then we set a point in Rhino. The coordinates are 0, 0, 0. Next, we copy this point in the Z direction using the Move component. After inserting the unit vector parallel to the z-axis, we need to set up a range, for example, from 1 to 10. Then we enter height for this slider name. Afterwards, we create a line between these points using the line component. In the next step, we copy the line as well as the points in the x direction. To do that, we insert the move and the unit vector parallel to the x-axis components. We also need to create a new range, for example, between 1 and 15. Then we enter length for this slider name. We repeat this for the points, as you can see. Now we copy all the lines and points in the y direction using the move component. We also need to insert the unit vector parallel to the y-axis. Then we set up a new range, for example, from 1 to 10. Then we enter width for the slider name. After that, we create lines in the longitudinal direction. First, we need to determine which points will be connected to each other. Then we connect these points to each other using the line component, as you can see. Now, we divide these lines into equal segments using the divide curve component. By default, the value of the segment number is 10. We set up a new range, for example, from 1 to 15. Then we enter number of segments for this slider name. Afterwards, we connect these points to each other using the line component. In the next step, we create lines for struts. To do this, we need to copy the 2 points that are parallel to the y-axis in the x direction using the move component. We also insert the unit vector parallel to the x-axis. After that, we set up a new range, for example, from 0 to 5. We enter distance for this slider name. As you can see, we need to reverse the direction. We can do this by right-clicking the motion and selecting the expression. Then we enter -x and click Commit Changes. We repeat this for the second point. Afterwards, we create lines for the corresponding points using the line component. Next we create the diagonals. We need to determine which points will be connected to each other. After that, we connect these points to each other using the line component. We can copy any line using the line command, as you can see. Now we hide these lines by clicking the mouse wheel and selecting Disable Preview. Then we make groups, enter names, and change the colors. Next, we put all the number slider commands together in a group to control all the parameters easily. Then we enter parameters for this group name. Now we assign members to these lines. We can do this by double-clicking the canvas and writing member. We begin with the columns. For this member type, we select the beam type using the value list command. Now we connect all the lines to the grasshopper line in the member component. In the next step, we define cross-section by double-clicking the canvas and writing section. Then we enter number 1 for the cross-section number and IPE 200 for the section name. Afterwards, we define the material by double-clicking the canvas and writing material. After that, we enter number 1 for the material number and S235 for the material name. Next we transfer this model data to RFEM 6. We have to insert the Dlubal component, RFEM 6 export component, by double-clicking the canvas, then writing, export. To start the export, we use the button command. We will overwrite the previous data in RFEM by using the Boolean toggle command and switching it to true. To perform the export, we double-click the button command. For the longitudinal beams, we assign another cross-section. Therefore, we copy both the member and section components. Now we have to change the cross-section number to 2 and the cross-section name to HEB 300. We repeat this for transverse beams. Here, we have to change the cross-section number to 3. The cross-section name to CHS 193.7 × 5. And the member type to truss. For the struts, we have to change the cross-section number to 4 and the cross-section name to IPE 100. We repeat this for the bracings. We also have to change the cross-section number to 5. The cross-section name to R20. And the member type to tension. In the next step, we will assign supports. To do this, we double-click the canvas and write nodal support. We also need to determine these nodes and connect them to the Grasshopper node in the nodal support component. Now, we would like to assign hinge supports using the panel command. Then we connect this panel to the support conditions in the nodal support component. Thank you for watching. If you have any questions, feel free to ask them in the comments below, and if you like this video, don't forget to like and subscribe. You can also visit our website at dlubal.com and search for anything you need.